Hello, I'm Les Bennett. I'm with the American Association of Pharmaceutical Scientists. It is my pleasure to host this special series of interviews with individuals who are recognized for their innovations and contributions to the pharmaceutical sciences. Speaking on behalf of the AAPS Distance Learning Committee, one of our goals is to develop a series of videotapes in which we invite eminent pharmaceutical scientists to discuss their points of view and their own personal contributions to the events, issues, and challenges that have shaped the direction of the pharmaceutical sciences. We will also explore their perspective on where the pharmaceutical sciences are headed in the future. Today it is our pleasure to have the opportunity to visit with Professor Ho-Leung Fung from the State University of New York at Buffalo. Lang, welcome.
Good morning, class.
So let's begin with your AAPS presidency. You were the 10th president of AAPS, right in the middle. And I'd like to get your perspective of where it went by the time you were president and what's happening to the pharmaceutical sciences since you were president.
Well, as you might recall, during my presidential speech, I sort of related a dream that I had as a theme of my presentation. And I, at that time, envisioned the AAPS would sort of merge into a international association where, in which our scientists had gained prominence. And I think in the past 10 years, this goal that I had envisioned, I think has been partially accomplished and is moving forward. And I think we are rapidly becoming the premier international association in the pharmaceutical sciences. Our memberships continue to grow, and our science continue to be very, very relevant in the whole family of biomedical sciences.
So you were a foreign student.
Yes, I was.
That came to the U.S. As a graduate student, having come, I believe, from Hong Kong and studied in Australia. So give us a perspective of a foreign student coming to the U.S. in the pharmaceutical sciences and where it went and how it affected you.
Yes, this is obviously a life-changing experience for me. I was a student at the Victorian College of Pharmacy, now Monash University, in the pharmacy program, and I had the opportunity to work with Adrian Albert at the Australian National University at that time, or with Takara Higuchi at then in Wisconsin. And I had chosen to work with Takiguchi because of his prominence in the field, and because his work, the integration of chemistry with biological performance of dosage form, was more appealing to me than perhaps the more chemical orientation of Adrian Albert. And I was fortunate that I had several years in a Western culture in Australia in which I sort of enjoy the spirit of inquiry, the spirit of debate, the spirit of disagreement in science. And I was very much at home when I first came to Kansas, where TAC had moved from Wisconsin. And actually, I had the honor to be his first graduate at the University of Kansas at the PhD level.
So tell us why you became a pharmaceutical scientist.
Yes, that's an interesting question. When I graduated from high school, I had three choices in my own mind. I could either have become a chemist, a chemical engineer, or a pharmacist because I like chemistry. And at that time in Hong Kong, to enter into the University of Hong Kong and become a chemistry major would invariably mean that I would be a high school chemistry teacher, which I fear tremendously because I was a high school student at once. And a chemical engineering was a possibility. And I had found that one of my friends was going to Melbourne, Australia, and we were able to room together. And so I'd apply to Melbourne, Australia. And, you know, as you know, some of these decisions that you made are based on very, very small things. The availability of a friend to go together was the cinching point for me to do pharmacy instead of chemical engineering.
Did you make the right choice?
I believe I did. I think the life of a pharmaceutical scientist is a very exciting one, and as you know, very few of us retire in the absolute sense because the work is so interesting. You continue to learn new things, you continue to expand your intellectual horizon, and there's always plenty of work to do. So I think this has been a very, very interesting career to follow.
So you made your decision, I think, very early to be an academic. And why don't you tell us what went into that and what you were thinking at the time and the results?
Well, actually, I had not made up my mind to be an academic when I graduated. When I was about to graduate, I should say. I was interviewed by a number of high-level manufacturers, Wyeth, a number of places, and were offered positions. It so happened that I was offered an interview at the University of Buffalo where I met people like Milo Gibaldi, Gary Levy, and the decision that I made at that time was thought that, well, I had the opportunity to do a postdoctoral kind of training in a different field. My training is in physical pharmacy, and the strength of Buffalo at that time was in biopharmaceutics and pharmacokinetics. And I thought it would be a very interesting experience because I didn't have to do a postdoc, and yet I was able to take their courses and learn at the same time, and I thought it was challenging. The fact that it has, 100 inches of snow a year also did not deter me that much.
Did they tell you that the weather was just like Hong Kong when they recruited?
Well, actually, I was told by my friends in Kansas, Arnie Repter, whom you might know, said you have to drive with a very tall antenna in the car because people have to see you around the corner. Yet that didn't deter me too much. I thought I always tell my student is that when your first job, the external environment is far less important than your work environment, which, whether it is motivating, whether it is nurturing. And I have found that because I still have a job at Buffalo, it's still my first job, as it were, that I think I have made the right choice.
You have an international reputation in terms of your science with nitrates. Why don't you give us a history of how you got into that field, of what attracted you, what were the problems then, and a little bit about what you think you've solved.
Well, it's interesting because, as I said earlier, I was trained with Tak Higuchi, and he had told me early on that if you learn thermodynamics, you don't need to learn anything else because you could learn other things based on the principle of thermodynamics. And when I got to Buffalo with our postdoctoral fellowship, I was looking for projects. In my days, pretty in the 1970, the preparation for a faculty position was not as rigorous as it is now. I was looking for a project, and it so happened I was reading what is called the Pink Sheets. Many of the students now don't know what it is. It is a trade a publication of the pharmaceutical industry. And I've seen many recalls of nitroglycerin tablets at that time. And I thought, well, this is a thermodynamic problem I could solve because the loss of nitroglycerin from the sublingual tablets was due to its high vapor pressure. And I had learned about complexation from Tak Higuchi, and I thought we could make very stable dosage forms. And indeed, we did, and we applied for a patent and had made very stable sublingual tablets. But after having made these sublingual tablets, we thought, well, it may not be released. Again, the thermodynamics of complexation and dissociation. So we thought, well, we have to measure the bioavailability of these preparation. And at that time, there was no analytical method that was available and to measure biological concentrations. And I think the luck has it in terms of being trained as a pharmaceutical scientist. I was able to go across the field of thermodynamics into bioanalysis because I knew a little bit of chromatography. And we had developed the first, I believe, workable assay for the biological determination of nitroglycerin in plasma. Since then, we were involved in the measurement of other organic nitrate, and it so happened that a clinical collaboration had developed with Professor John Parker at Queen's University. At that time, the clinical relevance of nitrate tolerance was not well established. And we conducted, I believe, the first study in which clinical tolerance to nitrate therapy was demonstrated in patients with stable angina. I was involved with the pharmacokinetic side of the work, and very interestingly, we found that in tolerance patients, the unchanged drug, actually the concentration had increased instead of decreased. And sort of that had embarked on a journey of about 30 years to understand the relationship between metabolism and tolerance.
Do you understand it?
Well, actually, I just came from an American Heart meeting where we had presented what we believe to be a unifying hypothesis of nitrate tolerance, and which could integrate the several existing hypotheses. And I hope that in the remaining years of my professional life, I am able to develop and validate this unifying hypothesis.
So you've trained a significant number of students over the years, and in this research area predominantly, and I think they've gone on to make distinguished careers. Let's talk a little bit about, training students, what your objective is, what you want them to do at the end of their experience, and actually what you do afterwards.
Yes. Almost all of my students had worked in the nitrate area, and very few of them had continued with it. The few perhaps is not large enough. Some have. But I had always maintained that the PhD training perhaps is not about a subject area, but about a research, a set of research values, including the habit of doing things, the way to do things, the way to critique your own work. So I'm very, very fortunate that many of my students had gone into leadership positions in bioanalytical area, in dosage form development area, in pharmacokinetic area, drug discovery. And I believe that it is the method of inquiry that is perhaps the most important in a PhD training curriculum. And the method of self-criticism, the method of reading literature, rather than, and the students probably don't like to hear it itself, rather than the subject matter itself.
I think I concur with
that.
How much contact do you have with these students afterwards?
Actually, I'm very, very proud that almost all of my students have remained friends, and we are in contact quite frequently. I'm with all my PhD students. I believe that I'm in contact with them either on a yearly or biannual basis. And we still talk about things and about career development, etc. And I think it is a good fortune of an academic advisor to have such continuing relationship.
If you were speaking with a group of college students or even high school science students today, what do you want to tell them about the pharmaceutical sciences, and should they go into the field, and what's the perspective for them?
I think it is a very, very exciting field of the pharmaceutical sciences. We are, unlike physicists, chemists, etc., we are by and large, I would say, and I don't want to generalize too much, that by and large we're not looking into questions of nature. We're looking into questions of application. So we are problem solvers. And I think we are able to adapt and integrate new knowledge. As you know, Les, in the 60s we brought in chemistry, physics, mathematics to develop the areas of physical pharmacy. We then brought in the areas of physiology, biology to develop the areas of biopharmaceutics, pharmacokinetics. We brought in the areas of quantitative pharmacology to quantify pharmacodynamics. And now we bring in genetics to talk about pharmacogenomics, etc. So we are always an adaptive science. We are always at the forefront of trying to use the basic principles that have developed by our colleagues in other sciences to apply to a real problem of therapy. So in my view, pharmaceutical scientists characterize ourselves of being principally focus in therapy. And so we have an objective in mind. We have an application in mind. And yet we are able to use basic sciences to solve these problems. So I think it's a very exciting intellectual area. And in practice, too, it's a very, very, lucrative area in terms of a career financially and very stable career because there is a very, very large industry that will support this work.
So your school is certainly one of the leading schools in the world in pharmaceutical sciences. And at your university, I think one of the most respected schools and departments. Tell us a little bit about your interaction across the disciplines at State University of New York at Buffalo, the pharmaceutical scientists, where they're viewed by your colleagues, both your clinical colleagues and your basic science colleagues.
Well, we are viewed very favorably, as you had suggested, because we are competitive at the NIH level. We're competitive in funding at the industry level. Continually, the university newspaper announces our accomplishment, various accomplishments, not a single individual, but a different individual of the department. So I think we are viewed as good scientists, solid scientists who could get things done. And so our interaction with clinical colleagues are always dependent on the discipline. My interaction with the cardiology colleagues has been very, very, very favorable. We sometimes have seminars together, and we collaborate in applying for grants, etc. And for basic scientists in the chemistry, biology, and the cancer therapy area in Roswell Park, there has been extensive collaboration between our colleagues and others.
You briefly mentioned when you were talking about where the pharmaceutical sciences, history of science, sort of let's talk about your perspective of the future of pharmaceutical sciences. Where is it going in the future and what we should expect to see or try to see?
Well, as I had mentioned, we are by and large an applied science. So we are always very adaptive in bringing in other disciplines. So when new disciplines such as genomics has come into being, we are able to develop a biotechnology area. We are able to develop pharmacogenomics within our cadre of colleagues. And so I see us as really an integral group of people who could do integrative therapeutics. We are, even in our university, you asked in university how we collaborate. Now the pharmacology department in our university, in the medical school, does not know how to do animal studies anymore. When they want to illustrate how system pharmacology work, they have to come to us to ask for input in terms of how to cannulate an animal, how to measure system. I think the molecular approach, the reductional approach, in my view, will turn its corner. And I have always tried to say to my students, molecular biology and molecular genetics are like bricks in a house. And yet, single bricks are very important to build a house, but you have to have the architect to see which room to build, how to build. And we, the pharmaceutical scientists, are the sort of architects to bring these basic materials to build up a usable structure, in this case, the house.
So when the outside public looks at scientists, or they might see these guys with long hair and lab coats and sitting in the lab and all day long, working night and day, and I think there's a perception that we don't have a balanced life. I think you have done very well in terms of a balanced family life and your academic life. Talk a little bit about how important that is, how it helps you, or the characteristics that are useful there.
Yes, I'm very fortunate. Of course, I have the support of my family, my wife, my children. During the formative year, as you know, being an assistant professor is not a walk in the park because there's a lot of hard work to be done. I'm fortunate that my wife is also trained in the pharmaceutical sciences, in the pharmaceutical sciences. And actually, in the early years, she would come to work with me at night back to the lab because I was the only one doing the experiments, and she was able to help. And it was a very, very enjoyable thing. I think, as in anything, a career has to have the support and the enthusiastic participation of your family. And I think it cannot be done, a successful career cannot be accomplished, in my view, if that support is not there.
So you're an outstanding scientist, but also very humble and self-effacing. So you've also said some good things about yourself, and you've also mentioned some of the people that you would interact with, Hack and Gary. Talk about these giants and their effect on you in pharmaceutical sciences.
I think, one of the most important things in science, I believe, is to find role models, because we all have a certain degree of intelligence, a certain degree of motivation to get into the field. But how to get to do something and how to behave, you really need good role models. I was very fortunate to work with Tack. Tack is a wonderful innovator. You could sit with him, and at the end of the meeting, your project will change, because during that time, he would have 15 different ideas to tell you, and then you will have to think about which one to pick. He's highly innovative, but more importantly, I learned from him very early on in my career that you don't have to be a mean son of a gun to be a successful scientist. He was well respected by his colleagues. He was well loved by his colleagues because of his leadership quality. I learned from Gary Levy how to be rigorous. I should not say that. I think while Tack is very innovative, he's not a person who would read the literature. So sometimes if you follow his suggestions, you find that, well, the work has already been done by somebody 20 years ago. I learned from Gary, however, that to be rigorous is very, very important. And I learned from Milo Gibaldi the organizational skill, I believe, that need to go into doing good work. So I'm very, very fortunate to have these three role models from whom I learn a great deal of how to behave, perhaps more than the scientific knowledge themselves.
Many academics outside of our field sort of shy away from the leadership departmental chairman stuff. But you were department chairman for a significant number of years, and I think did a very fine job. And I think let's hear about how important that is, how you can balance it, and is it something that should be done and we should aspire to, or something that the young academics should say, I never want to do?
Well, thank you, Les, for your kind words. I'm not too sure I've done that well as a chairman for the department, because it is a highly distinguished department. We had chairmen of Ino Nelson, Gary Levy, Milo Gibaldi, myself, and now Bill Jusko. And I think it is very important for those people who can do it to assume some leadership position in an academic area. I think the chairman, to me, had always been the person who would protect his colleagues from unwanted intrusions, rather than highly delegating all the work. We try to stay away from our colleagues and say, well, we don't have frequent meetings. We only consult with colleagues when decisions affect them or we know that are interest to them. So in that manner, I believe that a good chairman could, or chairwoman, I should say, can facilitate the growth of his colleagues, and in the meanwhile can facilitate his own laboratory as well, because the infrastructures that is developed in a department of successful colleagues will invariably help your own laboratory. So I'm very, very supportive of colleagues who would take up responsibilities to help the department grow, and as you have shown as an example, to take up leadership position in professional organizations such as the AAPS to also enhance our own discipline as well.
Just what I was coming back to, so thanks for that lead-in.
Yeah.
You've been very generous with your time in terms of supporting AAPS even beyond your presidency, and now serve as the editor of the AAPS Journal. So tell us that aspect of your career and how that's affecting you as a journal editor and what your goals are.
Well, I think being an academic, you like to read, obviously. And I think I enjoy being an editor-in-chief very much. I had served as an associate editor for the Journal of Pharmaceutical Sciences under the able leadership of Bill Higuchi, and I enjoyed my experience there. And I thought that being an editor hopefully can help foster the interchange of ideas and the growth of colleagues. In my own view, the AAPS has still an important role to play to provide educational and scientific debate opportunities among our industrial colleagues who tend, perhaps because of restrictions by the company, not write as much. But I think they have fantastic experiences to share. And so my goal with the AAPS Journal has been to encourage more industrial participation, to share their experience, to share their insight, and particularly through AAPS meetings when their presentation had already been approved legally by the association. And I believe that they have much to offer to broaden the science of our association, and I'm trying to encourage our colleagues in industry to participate as much as they can.
Again, following that theme of service to the association, the professional association, which you've been very generous with your time. How important is that for a young scientist? Is that something that should be on their radar, something that is important for them to do?
Well, it is important in the long run. However, times have changed, as you know, Les. In my days, early days, I could teach every semester. If I get one grant, I'm fine. Nowadays, the competitiveness of NIH funding is such that one has to develop new data, one has to develop a laboratory of repute to be able to compete in a meaningful manner. So I believe that younger colleagues should focus their energy to develop their career first. This is my own personal view, before branching out to do other things. And I think when they are reasonably well established, they should pay back into the field and contribute to our society.
Well, you've certainly been a role model for that. And Lang, I thank you very much for sharing with us today.
Thank you, Les. It's been fun talking about it. Yeah, bye.